yes, welcome back. Come on in. Come to the car stage. You don't need anything. All right. Very well done. Remember, we collected class points. This was a great transition, and who knows, we might collect the class points in this very lesson. Excellent.
In place.
Before we begin our lesson today, I just want to do a quick check-in with you all. If your brain was a battery right now, what percentage is it charged at and why? I need a show of hands for the kids whose battery charge is about 50%. Alrighty. And for those whose is below 50%. Alright, it was a late start. I assumed you guys would have been well tonight, but yeah, that's an assumption. Alright, who wants to share why? We have to be very brief, but I'm super curious as to know why the battery is less than 50%. Yes, Nora, go ahead.
I'm very tired. I'm excited for a
Yeah? Alright, Lee.
I slept really well, and I was just like, why do I have to get up? It's really starting.
Yeah?
Because when I sleep longer, I get really tired.
Who said the battery is up more than 50% today? Yes, right.
Because I slept.
That's good to know. Again, yes?
I slept pretty well because I slept really early and I had much more time to practice guitar again.
Excellent. So you had time to unwind as well. My battery is at 80% because I was super energized to teach the lesson today. A little coffee would bring me to 100%, but that's for later. All right. So let's begin our unit lesson for today. Can you move your bodies to the whiteboard? I'm gonna tell you the agenda for today. We're gonna do anchor chart. Have you guys thumbs up if you know what an anchor chart is? You don't know what an anchor chart is? This is exactly what an anchor chart is. Eyes on the small whiteboard. We're gonna fill it up together. We have a mini lesson on the carpet right here, and then I have a really fun partner activity. Then we move on to our packets that are also on your desks, and then I have a really fun choice board. Now, thumbs up if you know what a choice board is. Yeah, Nora, can you explain in a few words?
A choice board is like something digital.
Yes.
Or it can be like an arcade game or something.
Yeah.
Where you pick one, and that's the game that you play. It's like a mini game in that game.
Excellent. So now, if you actually make it mathematical, I've prepared a grid, a 9 by 9 grid, which means there are 9 squares, and you have different activities or tasks that you can do. And they're super fun. Some are tech related, some are just writing on the paper, and some are just discussing with the partners. So moving on, let's do the learning objective as always. I want us to read it out loud together. So let's go. I can multiply 3 and 4 digit numbers
by one digit number.
Alright, so I put an example here. 268 would be a 3-digit number, but 4 is a 1-digit number. 2092 would be a 4-digit number, multiplied by a 1-digit number. Alright, we move on to the anchor chart. Before I begin the multiplication chart here, I want to tell you that, remember yesterday's lesson? We did 2-digit numbers multiplied by 1-digit number. Today we're going to do something that may seem bigger, but I want to just show you that the strategy actually remains exactly the same. So there's nothing to worry about. We began, and I'm going to move a little bit further back in the unit. We began with multiplying 1-digit number with 1-digit number. See, more like 4 times 6. We showed it in an array. Remember the sticker sheet example? Yeah? And we skip counted also. Alright? Then yesterday we moved to stage 2, when we did 2-digit numbers by 1-digit numbers. How did we represent that? And a show of hands, how did we represent? 1-digit we represented with an array. 2-digit times 1-digit we represented with, yes, that?
It was the area model.
Excellent. So it was an area model. How did we go about solving this? Shall we solve and figure it out?
Yeah.
Yeah? Let's go. So who will tell me? Who remembers how we do this? How we come about to it? Me, yes.
So first, we divide the bigger numbers, so like 47,
Yeah.
into 2 different pieces, but like in a simplified version. So 40 and 7.
Alrighty. Let me just add something here. We do not divide, we decompose. Can we all say decompose together?
Decompose.
Alright, we are mathematicians. We need to use this vocabulary now. So I need everybody to use decompose when we're breaking apart a number. Alright, so what we're going to do is, first of all, as May said, we're going to decompose. How do we represent it first? By a area model. So I'm going to draw a rectangle here. And as May said, I am going to decompose 47. Now, is there a rule to decompose 47? Or I can just do whatever I want? What is the place value of 4? 40. And what's the place value of 7? 7. So we decompose using place value. Alright? These are some things that you have to remember. So 47 will become what?
40 and 7.
40 and 7. And we have what here?
6.
6. Now, who tell me how to fill up the area model. Zena, yes.
So you will do.
You need to tell me and I will write exactly what you're saying.
So you'll do 6 times 4, which is 24, and then you'll add the 0.
Alright, so I write 6 times 40, it's 24, and you add the 0. And what do I write here? Nadia?
6 times
7 is
42.
42. What would I call these? Can somebody tell me? They have a specific vocabulary term. Yes, Liv?
The sum.
No. Can you try again? Perhaps? Or does anybody else want to? Yes, Sam?
The value.
Alright. So I'm going to tell you. This is partial products. So if I write a number here, if I solve it without the area model, an equal sign here and a big number here, which we're not doing right now, that will be a product. But if we decompose 47 and do it in an area model like here, these are two products. So we call them partial products. We're basically decomposing the number and dividing the products. And we call them, what do we call them? Partial products. Alright. So now, if I want to write all of this in an expression outside of the area model, how do I go about it? Yes, Nora?
6 times 40 plus 6 times
Do I add brackets here?
Yeah. Brackets 6 times 7
Yeah.
equals
Yeah. What's 6 times 40? We can see, look here. Yeah.
Scorpions. For some level activities, scorpions.
Remember, all these steps are super important.
Scorpions.
Make sure we write the expression, we solve for each bracket, and then 282. Thank you, Gianmarco. So this is stage 2. This is what we did yesterday. What if I say that now we're talking about some big numbers, just like I mentioned in the beginning. So now what we have to do is 3-digit times 1 digit. Alright, so if I tell you how will you represent it? I'll give you an example. For instance, 7 times 243. Alright, what is happening here? Yes, Michael?
So like you're multiplying 7 by 243.
Why is it different from the previous one that I did?
Because like they're bigger numbers.
How bigger? We're adding one more place value. Alright, so now how will we represent it? Yes, Anne?
So what, using the area model?
Excellent. So we still use the area model. So the strategy remains the same. So I will write same strategy.
And you draw like a rectangle and then you split it into 3 with 1 on the side.
Who else has any predictions? Can you make any other predictions? I want to show of hands, new hands. It's okay to make mistakes. We're all learning here. Yes, Liz?
I think you make it like into 3 parts.
Alright, and then how do we decompose 243? What is the rule that we use? New hands? Yes, Rahim?
You decompose it like first the 200, then
Yes.
the 40, then the 3. The hundreds, the tens, and the ones.
Excellent. So 3 here, as Rahim says, 200. What will come here? Raya, 7? Alright. So who will walk me through how to solve this? Paula, yes.
7 times 200 is 1,400.
Excellent. And what about here? Yes, Jake?
40 times 7
Yeah.
equals 210.
200 and? Excellent. And then what about the next rectangle? Yes, Badia. 7 times 3. 21. Very quickly, tell me an expression. Yes, Nora. Keep speaking and I write.
7 times 200
Yeah.
plus 40 times 7 plus 7 times 3 equals 1,400.
Give me partial products. First.
1,000 equals
Yeah.
1,400 plus 280
Yeah.
plus 21
Excellent.
equals 1,670.
Excellent. Very well done. Does everybody agree with that? Yeah? Alright, so we use the same strategy, but what was the difference between this answer and this answer? Yes, Rahim?
That was 2 digits and this is 3.
2 digits. So there are more numbers? Can we say more numbers?
Yes.
More parts. Here also, we have more parts. Over here is a bigger number. Alright? Now, remember in the beginning, in the learning objective, we said we're actually going to move to 4-digit numbers. So let's try how can we use the same strategy? Or
I want to put this. Wait, I want to put as 9.
Is Michael correct?
No, I mean 30. 30. It's a 30.
Sorry. Here, what do we write here?
And then you.
What do you write here?
There.
Excellent. Thumbs up if you agree with Michael. All right. Who will help me solve this? Yes, Rahim.
So I mean, last problem, it's at 7 times 200, that's 1,400. So you just add a 0.
That's a great strategy, but I want to write all of this, and then I will use your strategy.
1,400, then add a 0.
13,000.
All right.
Add 0 to the 200.
Add a 0.
7 times 0? 30 times 7? Raise your hands. 7 times 9? Yes, Jake? Excellent. And quickly tell me the expression here. Who will tell me quickly? Sam.
So you do 7 times 2,000 in brackets, and then 7 plus 7 times 0 in brackets, plus 30 times 7 in brackets, then plus 7 times 9.
I'm running out of space here. All right.
Equals 1,400 plus 0 plus 210 plus 63,
Which equals what? Do we do standard algorithm or can you do it mentally? All right. Thank you, guys. So now over here, what do we see? Is it the same strategy?
Yes.
Yeah? What happens to the parts?
Just more.
Just even more parts. All right? So this is what I wanted you to understand. Do not be afraid when you see a bigger number because it's the exact same strategy. This is what mathematicians do. They find a pattern and then use that pattern to solve bigger and bigger problems. And this is exactly what we're going to do today. So I'm going to put this up here. I want you to discuss with your partners these discussion questions. What stayed the same and what got more complex? Your elbow partners, turn and talk. All right. Does anybody want to share, apart from what we did on the chart, what stayed the same? Yes, yes.
The strategy.
The strategy remained the same? Yes, John.
The 0
The 0
stayed the same.
stayed the same. But we did not ignore the 0. We never ignore the 0. We work it out, just like we work out any other place value. Sam?
You always multiply them just by one digit, like 1 digit by 1 digit, 2 digit, 3 digit.
That's a great observation. What became more complex? Yes, Nora?
How we, at the end, after we figured it out, when we went to 4-digit numbers, we put it mentally.
Yes.
So we had to, and we kept adding more columns and numbers.
Yeah. Yes, Logan?
So the numbers are bigger and bigger and bigger.
Absolutely. All right. That was good discussion. Let's move on to some of the problems that we have here. So what do we have here? Imagine your family's at a grocery store. So how many times have you accompanied your families to grocery shopping? Yeah, have you heard of conversations between your parents or among yourselves about how many cases of water shall we get? How many How many cartons of milk shall we buy? Yeah, that? Okay, that's relatable. That's good to know. All right. So let's read this problem and then we're going to solve together. Imagine your family's at a grocery store. You're buying water bottles because your family drinks a lot of water, which is healthy, and wants to save money by buying in bulk. What is bulk?
Like big, massive, like
Large quantities. Yeah. Right. Each case of water bottles has 128 bottles. Your family decides to buy 4 cases for the month. How many water bottles will your family have?
4 times 158.
All right. So where do we begin? So Jake helped us here that our starting point would be to first note down the expression. This is called an expression. All right. Now what do? We know the strategy. We solved all the problems earlier on the anchor chart. Let's go. I want you to take a whiteboard and a marker and do it. 5, 4, 3. I want to see you guys back in your seats. 2. Guys, we didn't paper transitioning. It was just a whiteboard and marker and eraser that we usually do all the time. So this really did not require that much time. Put up your whiteboards when you're done. So that's good. Very well done. Very good. I do feel like you guys have gotten the hang of it. I see all correct answers and all the steps. Very well done. I'm so happy. So next time you're at the grocery store with your family, listen to this kind of math. These adults are very sneaky. They do all these steps in their brains while we're writing all these steps because they've had practice writing all of this in grade 4, 5, and so on, right? So don't think that they did it overnight, but they're actually mentally doing it in their heads. So the next problem is your family is planning a birthday party. We all do that. You know, our parents throw us amazing parties, even if they're low-key or on a big scale. They want to buy cookies and cupcakes from the bakery to serve guests. One box from the bakery contains 1,265 treats. Cookies and cupcakes mixed, what a dream. Your family buys 3 boxes. How many treats will they have for the party? Alright, what is the expression that will come out of this problem? Yes, Paul.
3 times 1,265.
And who can tell me what problem is it on the anchor chart? What number problem is it on the anchor chart?
Stage 4.
Stage 4, because it is a 4-digit number. Alright, what did we agree on? What do we do with the 4-digit numbers? What remains the same?
This bracket.
Absolutely. Let's go. Yeah. Alright. Excellent. You guys have really got the hang of it because I haven't seen any wrong answer here. We'll have to. Can you do the addition again? Can you do the addition again? But we're going to do this fun activity. Now you have to generate your own problem. Now it's your turn. You have to think about a real grocery or family shopping scenario that involves a large quantity. You might think about items the family buys in bulk that we just spoke about. Water bottles, snacks, cans, things you see at the grocery store. Eggs per carton, tissue rolls per pack, items per shelf.